Section 5.4 is on analyzing graphs of polynomial functions. So we're going to be graphing some polynomial functions on our calculators and seeing what's going on with them. So right now I'd like you to take a look at the graph of y equals x cubed minus 4x squared plus 3x plus 1 on your calculator. And I've actually graphed it here. There's the function. Let's graph it. Okay, and as you can see, it's kind of tight. It's kind of hard to see what's going on. What I'm really interested in here with this graph is where it's crossing the x-axis, and it's kind of hard to see. So I'm going to show you right now how to change the window. Notice in the notes I say use a 4x4 window. So we're going to hit the window button here at the top, and mine right now is defaulting to a minimum x value of just over -16, just past -16, and up to 16 in the x. I'm going to change this to a -4 and my x maximum to a 4. I'm going to leave my x scale as 1, and I want my y minimum and y max to also be 4. And so what this is going to do is it's going to allow me to kind of zoom in on the graph a little bit. So you can see, okay, that it looks like it's crossing right here, and crossing right here, and crossing right here. So let's go ahead and use the table function. I've actually already done this in the notes. Use the table function and take a look at putting the values from -4 to 4. And don't worry that some of these are like ridiculously huge. Because basically what we're looking for is we want to see what's going on where it crosses the x-axis. Okay, so there are my values of y. I'll look at this one here. My values of y for x equals -4 to 4. And so I've copied that table here. Notice that it has, actually let's start here. Notice that it has 3 real zeros. One of the real zeros is between x equals -1 and x equals 0. That would be this point right here. It has another real zero between x equals 1 and x equals 2. And then it has another real zero between x equals 2 and x equals 3. And remember, these are the points. The real zeros are the points where it crosses the x-axis. Let's take a look at the table. So this is kind of interesting. Notice my y values, they're negative, and then they switch to positive, and then they switch to negative, and then they switch to positive again. So when I'm going from a y that is negative to a y that is positive, that's what's going on right here. So right here y is negative, right here y is positive, and so in between there is where my 0 is going to be. So I'm going to have a 0 for y somewhere right in between there. The same thing here. My y is going from a +1 to a -1. That's like right here, from a +1 to a -1. That's this interval right here. And so somewhere in between there, my y is going to be 0. And then the same thing here between -1 and +1. I'm going from a negative y value to a positive y value. That's this interval right here. So somewhere in there I'm going to have a 0. So that's what I say basically here. Notice in the table that between x equals -1 and x equals 0, y changes from a negative to positive value. This also happens between x equals 1 and x equals 2, and between x equals 2 and x equals 3. So this is where the real zeros are, where the graph crosses the x-axis. So you can see this both in the graph of the function, where it crosses the x-axis, but you can also identify it in the table when you have what they call a sign change. When you're going from negative to positive or from positive to negative, you know that y equals 0 somewhere in between there. So now what we'd like to do is be a little more exact. Actually, you can't be totally exact, but be a little more exact in finding these zeros. To do that, you can use your calculator to do that. We're going to hit second trace, and then we're going to ask it to find a 0. We're going to move the cursor to the left of where that 0 is and hit enter. Move the cursor to the right of the 0 and then hit enter twice. So let me show you what that looks like on the calculator here. So I'm going to do second trace, and notice that's the calc menu it says up here, calculate. I'm going to go down and say find me a 0, hit enter, and now you'll notice that you have this blinky cursor. Okay, what I want to do is put that cursor somewhere to the left of this 0. So let's see. I'm going to use my left button, and I'm going to put it right there. That's fine. That's somewhere to the left of my first 0. Hit enter. Now I'm going to move it to the right, somewhere like right there, and hit enter. And you'll notice on my calculator that it's drawn a vertical line here and a vertical line here. Unfortunately, it's a little too close to the y-axis. So what it's going to do is look for basically a sign change in the y between those two vertical lines. And if I hit enter again, it tells me that I have a 0 at x equals negative 0.2469 and so on. Okay, so that's 1, 0, where x is approximately equal to negative 0.25. So what did I do? Yeah, so I rounded that to the nearest hundredth, to the 2 decimal places. Okay, now let's find our other 0. Let's find a really close decimal approximation for this 0 that's right here. So again, second trace, go down to 0, hit enter, and I'm going to move my cursor somewhere to the left, and it doesn't have to be exactly close, somewhere to the left of this 0 right here. And so that's a good spot. I'll hit enter. Now I'm going to move my cursor somewhere past that, so I can do like right there, and hit enter. So now what the calculator is going to look for is between these two vertical lines, where does the graph cross the x-axis? It's telling me to guess. I don't want to guess. I'm just going to hit enter again. And it tells me there is a 0 at x equals 1.445, so on, rounding that to the nearest hundredth at approximately 1.45. And that's what I have here. And just for more practice, let's do the third one. Let's see if we can find where an approximation for this 0 right here. So again, second trace, go down to 0 and hit enter. Move your cursor somewhere to the left of it. It doesn't have to be super exact. It just needs to be somewhere on this side of your 0. Hit enter. Let's move to the other side of the 0. Somewhere up here, and hit enter. And remember, now it's going to look between those two lines. Your calculator may not actually draw lines. You may just have to look for these little arrows at the top here. And then hit enter again. And we have a 0 at approximately x equals 2.80. 2.80. So that's how you can find a pretty good approximation of the zeros. They're not exact, because if you were to use the, well, we can't use the quadratic formula on this. If we were to calculate it more precisely, there would actually be a square root in this. So I want you to also notice that the graph has a maximum value between 0 and 1. Let's take a look at the graph here. So there's a high point right in here, that we call that a relative maximum, and that's between where x equals 0 and x equals 1. We call this a relative maximum because the highest point is actually positive infinity. Because this graph goes on forever in this direction, because it continues to increase, the maximum is positive infinity. But this is a relative maximum because in this area that's kind of the highest point. It also has a relative minimum between 2 and 3. Let's take a look at the graph for that. So relative minimum would be somewhere around in here, and that looks to be between where x equals 2 and x equals 3. Now you can find the x-coordinate of the relative maximum and the relative minimum by using your calculator. Again, we're going to do second trace. Remember, that was our calculate menu. And depending on which it is, we're going to select 3 for a minimum or 4 for a maximum. Again, we're going to do our left bound, the left boundary we want to set, hit enter, the right boundary, and we'll hit enter and then enter again, and it will give us our relative max and min. Let me walk you through that. So right here we have a relative maximum. So I'll do second trace, and I'm going to go down and look for a maximum value, and I'm going to put my cursor somewhere to the left of that maximum. So it's going to take me a little while to move it over there. Okay. There we go. Okay, so anywhere here to the left of it, I'll put it right about there, and hit enter. Now I need to move it over here to the right of the maximum, and hit enter. And notice again, it's set these two little boundaries. Okay, so what it's going to do is it's going to look for what is the highest y value between these two vertical lines here. And if I hit enter again, I get that I have a maximum at x is approximately equal to 0.45. So I have a relative max at x is approximately equal to 0.45. Now let's look for that relative minimum. That's going to be a spot down here. So again, second trace, and I'll go down to minimum and hit enter. Move my cursor, actually anywhere in here would be fine. I'm just going to get a little bit closer to it. Okay, so that's kind of the left boundary. And now let's move it over to the other side of the minimum. Somewhere in there is good. Hit enter again. That's my right boundary. So it's going to look between these two lines for what is the lowest point. Hit enter again. Notice the cursor goes to the lowest point and it tells me that I have a relative minimum at x equals 2.215, or rounding that approximately 2.22. So I have a relative min at x is approximately equal to 2.2. So that's how you use your calculator to find relative max and relative min. Oops, did I go too far? Hold on. There we go. Okay, so I'm going to do a couple examples, and this is what I want you to do in the homework. For each given function, I want you to graph it on your calculator, copy the table and the graph on graph paper, find the x-coordinate of each real zero using your calculator, round to the nearest hundredth, and find the x-coordinate of the relative max and or relative min, and round that to the nearest hundredth. So let's take a look at this first function here. f of x equals x cubed plus 4x squared minus 5x. So let's graph that on the calculator. So I'll clear this one out. So I have x to the third power plus 4x squared minus 5x, and hit graph. And actually I might need to zoom out a little bit. I'm not sure what's going on with this one here. Yeah, I can't see. So I'm going to go to, because I had made my window a little bit smaller, I basically made it a 4x4 window. I'm going to go to zoom and hit standard so I get a better view of what's going on here. Whoa, that really goes up kind of high. I think I'm going to have to change my y boundary here, because notice I'm going to have a relative max up there and I can't see it, and I've got to be able to see it. So let's go to window, and I need to make my y maximum a little bit more. So let's try 20. Let's try a y max of 20 and see what happens. Oh, let's see, graph. Whoa, it's still not getting it. Let's go a little bit higher. Okay, I think I've got to go a little bit higher. Let's do a y maximum of 30. Oops. And graph. Okay, now I got it. All right. So, wow, that's a pretty high point right there. But it looks like, so 1, 2, 3, 4, 5. I think I'm going to start making my table at like -6, and it looks like I should probably go up to +2. So let's go ahead and make the table from -6 up to +2, because that's kind of where all the action is happening. Okay, and I do have some really big values here. So I'll go ahead and copy that over here. So when x was -6, I had -42, -5 is 0, -4 was 20, -3 was 24, -2 is 18, -1 is 8, 0, 0, 1, 0, and 2, 14. So let's go ahead and graph that, and I think what I'm going to have to do is, in my y direction, I think I will be counting by 2s. Just because my y's get so big, and what I have here is a 10 by 10 graph. So let me plot the point. I can't get -42. But let's do negative 5, 0. 1, 2, 3, 4, 5, negative 5, 0. And then from there it's going to be going down. So I'll draw that in just a minute. Negative 4, 20. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Whoa, okay. Negative 3, negative 24. Okay, I'm just going to kind of eyeball that one is up here. And then negative 2, negative 18, or negative 2, positive 18. Negative 1, 8, 0, 0, 1, 0, and 2, 14, I think is right there. Now, this is going to be kind of hard to sketch it because, like, this is really strange. This is not going to be a straight line. So I'm going to go back and look at my graph and see what it looks like. Let's take a look at the graph. Okay, so it goes up, and it actually, I think it actually ends up going up past 24, and then notice it dips down here between 0 and 1. So my graph is going to look something like this. And it goes way down real fast, actually a lot faster than that. And then between 0 and 1, and then it goes up again like that. So my graph looks something like that. It's a little fuzzy over here. So what I need to do is find my zeros, and actually I don't have to use the calculator for this because I have zeros right here, and right here. Remember, what we're looking for is where does y equal 0. So I have real zeros at negative 5, 0, and 1. Remember, it's the x-coordinate where, and actually I think I'll write it as x equals. It's the x-coordinate when y equals 0. So I have real zeros at x equals negative 5, x equals 0, and x equals 1. Now I need to find a relative max, and I probably have a relative max right around here. Okay, and then I'm going to have a relative minimum right about there. And those don't appear to be nice points, or I can't really tell what they are. So I'm going to have to use the calculator. So I'm going to have a relative max at x is approximately equal to something. I'll have to figure out what that is. And I will have a relative minimum at x is approximately equal to something. So let's go back to the calculator and figure that out. Maybe I'll look for this relative max right here. So second trace, I'm looking for a maximum, and I need to move my cursor to the other side of it. So that's a good spot. Hit enter, and move it to the right of the maximum, hit enter, and then hit enter again. So I have a relative maximum at negative 3.189 and so on, so let's round that to negative 3.19. At approximately negative 3.19. And now let's find the relative minimum. Second trace, I'm looking for a minimum. Move the cursor anywhere to the left, and I could actually even do it right there. And then somewhere to the right of the minimum. How about like right there? Hit enter again, and it tells me that I have a relative minimum at x equals 0.525225 and so on, or approximately 0.52. At approximately 0.52. So that's what I'd like you to do for each function. Graph it on your calculator, make the table, draw the graph, find the zeros. In this case, the zeros were really pretty easy because we actually saw the zeros, and then find the relative max and min, and if you have to do any approximations, to the nearest hundredth, 2 decimal places. And let's take a look at one last example here. F of x equals x to the 4th plus 2x minus 1. So let's graph that on the calculator. Clear that out. X to the 4th plus 2x minus 1. Wait, 2x, yeah, 2x, not 2x squared, right? Yeah, just plain 2x. Okay? And, you know, I'm going to change my window back to kind of a normal window, I think. So I'm going to do zoom 6 and see what this looks like. Okay, and it doesn't seem to be coming back down anywhere. It is an odd function. I don't know why this is displaying this here. It is an an even function because it's an x to the fourth, which means the arrows are both going to be going in the same direction. And in this case, it looks like they're going up, which makes sense because my coefficient of x to the fourth is a positive 1. So let's make our table and let's make it go from, oh, I don't know, let's say -2. There's -2. I can see better over here. So like from -2 over to +2. Second table, -2, enter, -1, 0, 1, 2. Okay, so those are kind of reasonable values. Notice my 19 is kind of high, but I'll just go ahead and copy that. So my x and my y, and I had -2, 11, -1, -2, 0, -1, 1, 2, and 2, 19. Now notice I don't have any zeros in my y column, but I do have, this goes from positive to negative right here, so I know there's going to be a 0 in there. And right here it goes from negative to positive, so I know I'm going to have a 0 in there. So let's go ahead and graph those points. So -2, 11, kind of fudge up there, -1, -2, 0, -1, 1, 2, and 2, 19 is going to be like way the heck up here, so we'll just kind of pretend it's up there. And then let's take another look at our graph to see if there were any little funny jogs or anything in it. So it's not like a perfect parabola, it's actually a little pointy kind of down there. So we'll make it look something like this. And it goes up just real high. We'll just kind of fake it like that. Okay, so I have zeros in here between -2 and -1, which makes sense because that's where my y's went from a positive to a negative, between -2 and -1. And then I have a real 0 in here between 0 and 1, and that makes sense because my y's went from a negative to a positive. So let's go ahead and find those using the calculator. Second trace, to find a 0, I'm going to go to 0. Move my cursor to the left of that. That looks good. Enter. Move my cursor to the right, so something right in there. Hit enter, and then hit enter again. And I can see that I have a real 0 at approximately -1.395, so I'll round that to -1.40. So I have a 0. Zeros at x is approximately equal to -0.140. And then I will have one more. Let's find that one. Second trace, looking for a 0, and I'm going to be going for this one over here on the right, so I need to move my cursor a little bit closer to that, so that's probably a good spot there. Hit enter, cursor to the other side of it, hit enter, and hit enter again, and I have a 0 at 0.47, so at approximately 0.47. Okay. Now I need to look for relative max and relative min. Well, since this is going up in each direction here, I have no relative max. So there's no relative maximum. But I will have a relative minimum at, and I need to figure out what that is. That's going to be this low point down here. So let's go back to the graph, second trace. I'm looking for a minimum. I'm going to move my cursor to the left of that low point, hit enter, and then move my cursor to the right of that low point, and hit enter, and then hit enter again, and it tells me that I have a minimum at approximately -0.79, approximately -0.79. So that's what I would like for you to do on the homework. is to graph the function on your calculator, copy the table, copy the graph, and use the second trace menu to find your zeros, decimal approximation for your real zeros, and decimal approximations for your relative max and relative